Boys and girls, this is Mr. Manise here again with another very exciting video. In this video, I'm going to walk you through how to solve each of the problems on our rational roots and graphing higher order polynomials quiz reviews. So let's go ahead. Oh, my disclaimer as always. Need you guys to work all these problems on your own and then come to the video and see where you might have any misunderstandings or need extra clarification. Let's jump right in. Number 1 and number 2 are simply asking us to state the possible rational zeros for each of these functions. So this is my plus or minus p over q, or really what you guys need to focus on are the factors of the constant term divided by the factors of the leading coefficient in the front highest degree term. All right, so the factors of 5 are simply going to be, and I'll just write a plus or minus out front. It's going to be plus or minus 1 and 5. Those are the only two factors of 5. Over the factors of the leading coefficient. The only factors of 2 are 1 and 2. Okay, so we've got several different combinations here. I could have a 1 divided by 1. So I'll have a plus or minus 1. I could have a 1 divided by 2. That's going to be a plus or minus 1/2. I could have a 5 divided by 1, that's plus or minus 5, and I could have a 5 divided by 2, plus or minus 5/2. All right, so what our rational roots theorem says is that the zeros, the solutions to my cubic, my quartic, my quintic, whatever degree polynomial, the solutions, the zeros, will be in this list of possible zeros, okay? Just because it's in this list doesn't mean it's a zero, but the zeros are in this list somewhere. Okay, the next one here, I'm looking at my factors of my constant divided by my factors of the leading coefficient. So for the factors of 6, I'm going to have 1, 2, 3, and 6. And for the leading coefficient, I got 1 and 2. So I'm going to have a 1 over 1. I have a 1 over 2. I have a 2 over 1. I have a 2 over 2, which is 1, but I already have 1. I don't need to write that twice. I have a 3 over 1, plus or minus 3. I have a 3 over 2, plus or minus 3/2, 6 over 1, and 6 over 2, which is 3, but I already have that here. Okay. All right, so I can also check this just to make sure. I have 1, 2, 3, 4, 5, 6 numbers, so I should have 1, 2, 3, 4, 5, 6 different combinations. 1, 2, 3, 4 numbers, 1, 2, 3, 4 combinations. All right, so the next one says state the possible zeros, which we just did, and then it says find all the zeros, stating the multiplicity if it's applicable. Okay, so for sake of time, guys, I'm not going to go through what we just did. I'll just go ahead and write down our possible roots here. For number 3, our possible roots are plus or minus 1 and plus or minus 1/5. Okay, now, before I get started, to find the zeros, most of the time we're going to use synthetic division to test our zeros. Okay, we can use our graphing calculator to graph this polynomial. We can look at where it crosses the x-axis, the x-intercepts, and get an idea of, okay, let's start with this 0 and test it with synthetic division. However, before I do that, I always want to look to see, can I factor this right out the gate? Okay, so in this case, I actually, if I were to draw a curtain here, if I were to do the curtain here, and see if I could pull out a GCF on both sides, just like we're factoring by grouping here. I could pull out an x squared, and that's going to leave me with 5x plus 1. Here I can pull out a negative 1. That's also going to leave me with a 5x plus 1. Okay, so in that case, I have two different factors. I have 5x plus 1, and I have the stuff left over on the outside. I have the x squared minus 1. Okay, so, but then that's not fully factored. I can still factor x squared minus 1, and now you guys can see why we worked so hard last year and this year on working on factoring, so you guys can immediately recognize these things. This is a special case. That's just a difference of squares. So that x squared minus 1 just factors as x plus 1 times x minus 1, difference of squares. So my final factor form, I have 5x plus 1 times an x plus 1 times an x minus 1. Okay, so now I just solve each of those. I flip those two signs. So x is going to be equal to negative 1 and positive 1. Move the 1 to the other side, divide by 5. That's going to be a negative 1/5. Okay, so those are my zeros. I don't have any multiplicities. All these are multiplicities of 1. Now, if you don't recognize, guys, right out the gate that your cubic or your polynomial is easily factorable, watch what happens if I use synthetic division. I'll get the same thing. It's just another way to get the same answer, which is one of the main reasons why I love math so much. Different ways to get to the same end result. Okay, let's graph this. And let's go 5x raised to the third plus x squared minus 5x minus 1. And let's graph that. Let's get some ideas. First of all, if your graph is all out of whack, looks weird, you can press the zoom button, and then press 6, zoom standard. That gets you back to your standard window where your x and y axes are in increments of 10 and negative 10. Okay, so there's my polynomial, so I want to find a good starting spot. Well, it looks like it crosses right there, and we already know the answers, but if you had done this to begin with, it looks like it crosses at -1. Okay, so let's test that. So I'm going to test -1 using synthetic division. Okay, so I have a 5, a 1, a -5, and a -1. Bring down the 5, multiply -1 times 5, that's -5, that's -4, -1 times -4 is +5. Excuse me, check that. +4, -5, plus 4 is a -1. -1 times -1 is a +1. Those cancel. So I get a remainder of 0. So now I'm left with a quadratic 5x squared minus 4x minus 1. And then, so how do you factor this? Okay, well, again, you'd have to do the a times c thing. 5 times -1. What are the factors of -5 that add to -4? That's going to be a -5 and a +1. Okay, so actually let me just rewrite this up here. 5x squared minus 4x minus 1. So I'm going to split that. I'm going to split that into a -5x and a -x. Bring down the 5x squared, bring down the -1. Now I can draw my curtain, and now I can group. I can pull out a 5x. That's going to leave me with x minus 1. Here, all I can do is pull out a -1. That's going to leave me with x minus 1. Yeah. Okay, so I'm sorry, I knew I made a mistake somewhere. Sorry about that, guys. That should be we split this into a -5 and a +1. That should have been a +1. Excuse me. See, I knew something didn't check out because when I went back to redistribute, it didn't work. So that should have been, that's just an x. So I can just pull out a +1, and then that will leave me with x minus 1. Okay, so now I have x minus 1, and then I have the stuff left over on the outside, 5x plus 1. And then, so my two zeros, I flip that sign, so I get, there's the 1. Move the 1 to the other side, divide by 5, there's your -1/2, and then the -1 is the one that we tested using synthetic division. Okay, so why did I do all that? So I did all that to show you that we did synthetic division, we got it down to a quadratic, and then we factored the quadratic, and then we solved and got our zeros up here. But if you notice on the front end that your polynomial is already factorable, we just saved ourselves a lot of work. This was a whole heck of a lot easier. We did the grouping up here, we did the grouping down here, but the second way we had to do some synthetic division. If you notice that it's factorable right out the gate, you don't even have to mess with synthetic division, okay? So always see if your polynomial is factorable. Okay, all right, so let's go to the next one here. So the possible roots, I'll just write that down really quickly. We got a bunch on this one. ±1, ±5, ±7, ±35, ±1/2, ±5/2, ±7/2, ±35/2. And some of you guys, I know some of you guys are looking at this and saying, Mr. Manish, really? Why do we have to write out all of these possible zeros if I can just go to my calculator, look at the graph, and see where it crosses the x-axis? And guys, for the most part, you're right. But you'll notice here, I've got some wacky numbers here. There might be a scenario if your first and last terms are fractions. If I were to really beef this up and throw you guys a challenging problem on a test or quiz, if the first and last terms are fractions and all of your possible roots are fractions, how are you going to go to your graph if you got something, you know, here's 1 and 2 or whatever, and you got stuff that's doing this all over the place. It's not easy to see from the naked eye exactly where it's crossing if it's not crossing at whole numbers. Our zeros might be 2.5 or 3.5 or 17.5 or whatever. So that's why it's helpful to list out these possible rational roots so that when you go to your calculator, you can say, oh, it looks like it crosses at 2.5. Is that one of my possible roots? Well, yes, it is. Okay, so it's just kind of confirmation there for you. Okay, but we will go to our calculator and let's graph this. Can I factor this? That's the first thing. If I draw my curtain and pull out an x squared, you can easily see that I'm going to have a 2 and a 5. Whoa, 11, 30. Yeah, that's just not going to happen. This is not going to be factorable by grouping. All right, so now I'm going to have to go to my graph, and I'm going to have to get some possible starting places. So let's type in 2x raised to the third minus 5x squared minus 11x plus 35. Let's graph that, see what it looks like. Okay, well there you go. This is what I was just talking about. That doesn't cross at a nice whole spot. Okay, so this not, we're going to have a 0 that's not at a whole number. Okay, so what does that look like? That looks like 2.5. Okay, well I just alluded to that. Okay, well there's my 2.5. You know, this could have been 4/3. You know, so this is telling me, okay, this is probably the 2.5. All right, so I'm going to test. And I know we haven't done this yet, guys, with fractions. You guys are gifted. This is the block class. You can do it. All right, so let's test negative 5/2. Okay, that's crossing at the negative. Looks like it's crossing at negative 2.5. Let's test negative 5/2. 2, negative 5, negative 11, 35. Bring down the 2. Negative 5/2 times 2. Negative 5 times 2 is negative 10. Negative 10 divided by 2 is negative 5. Negative 5 minus 5 is negative 10. Negative 5 times negative 10 is positive 50. Divided by 2 is a positive 25. Add those, that gives me 14. Negative 5 times 14 divided by 2, that comes out to be negative 35. Okay, so if you're not sure, just type that in your calculator. Negative 5 divided by 2 times 14, you get negative 35. All right, so now I'm down to my quadratic, so I have 2x squared minus 10x plus the 14. Okay, can I factor this? Okay, well, it's not a special case, so I'm going to have to do let's try to do the rainbow thing here. 2 times 14, that gives me 28. What are the factors of 28 that add to negative 10? 1 and 28, 2 and 14, that doesn't get me there. 4 and 7, that doesn't get me there. Okay, we can't factor it. Can't factor. So when we can't factor, what is our last resort? Quadratic formula. Quadratic formula. So my A is 2. My B is negative 10. My C is 14. And this also you guys could have predicted, because when we looked at our graph, where does it cross the x-axis? It only crosses in one spot. Okay, we don't have any shake and bake. We don't have a multiplicity of 3 or any of that kind of stuff. It just goes straight through. But this is a cubic, right? So I have to have 3 solutions. So I'm already thinking in my mind, well, there's one of my solutions. The other 2 are going to be what? They're going to be imaginary because we don't have 2 more x-intercepts, okay? So if they're imaginary, that's telling me I'm going to have to do some square root method with a negative or quadratic formula. There are going to be some i's in here. So I'm already thinking that. Okay, so quadratic formula is going to be negative b, but my b is already negative, so negative 10 plus or minus the square root of negative 10 squared minus 4 times a times c all over 2 times a. I'm not going to go through all this, guys. I've already made videos on quadratic formula. You guys should be proficient at that by now. If you type all that into your calculator, you should get 10 plus or minus the square root of negative 12 over 4. Okay, and then here's where we got to break this down, just like we learned before. Square root of 12, that breaks down into root 4 and root 3, which is just 2 root 3. Okay, so all that simplifies to 10 plus or minus, but there's a negative in here. Okay, so what pops out? An I pops out. So instead of plus or minus 2 root 3, it's plus or minus 2I root 3. over 4. That I just tells me there's a negative in the radical. I've got some imaginary solutions that don't cross the x-axis. Notice that all three of these guys are divisible by 2. So that is going to simplify to 5 plus or minus I root 3 all over 2. Okay. Actually, I shouldn't put a box around that. That's not my final answer. So all of our roots, so our roots are the 5 plus or minus I root 3 over 2. That's 2 of my roots, plus what? Plus the other root that we tested with the synthetic division. Okay, that is my official final answer. The 2 imaginary roots and the negative 5/2 or the negative 2.5. Okay, let's keep going. The next one here, I have 3x to the 4th minus 7x to the 3rd plus 5x squared minus x. Okay, so I'm going to go ahead and list out your possible roots. I need to point this out. There is no constant here, so this is a, sorry, I wrote over it. This is a plus 0. Okay, plus 0. So it's 0 over the plus or minus the factors of 0 over the factors of 3. So your possible roots are 0, plus or minus 1, and plus or minus 1/3, actually. Okay, so, all right, so if we want to test this, okay, so if I draw my curtain here, guys, if I draw my curtain, you can see that you can't factor. I'm going to have some 3s and 7s over here. I'll have some 5s and 1s over here, so that's not going to work. Okay. All right, so if I go to my calculator, y equals, I'm going to type this in. I'm going to have 3x raised to the 4th minus 7x raised to the 3rd plus 5x squared minus x. And I'm going to graph that. Okay, so that's kind of interesting. So where do you want to start on this one? It looks like maybe it crosses at positive 1. So I could test, let's test 1. Okay, so we've got 3, negative 7, 5, negative 1, and I have to put this 0 right there, guys. We don't have a constant. Remember, you got to fill in all the holes there. So that's going to be 3. 1 times 3 is 3. That's minus 4. 1 times negative 4, negative 4. That's 1. 1 times 1 is 1. That's 0. 1 times 0 is 0. Okay. So my remainder is 0. So once again, I don't have a constant term right here. So this is gonna, that's my constant. That's my x. That's my x squared. That's my x cubed. So I'm gonna have 3x cubed minus 4x squared plus x. Okay. So now I'm still not down to my quadratic. So one way to continue was to do synthetic division again. But what do you notice about this? Okay, I can pull out a GCF. Okay, GCF. They all have an x, and you actually could have pulled out a GCF on the front end as well, but we'll get the same thing. It does, at some point, you will be factoring out an x. It really doesn't matter when you pull out the x. So I'll factor out that GCF of x. That's going to leave me with 3x squared minus 4x plus 1. Okay, and so now I'm finally down to my quadratic. 3x squared minus 4x plus 1. Can I factor that? Okay, a times c. What are the factors of 3 that add to negative 4? That's going to be a negative 3 and a negative 1. Okay, so I'm going to bring this over here. I'm just going to ignore this x for just right now. All right, so I've got 3x squared minus 4x plus 1. I'm going to split this guy. I'm going to split it into the negative 3x and the negative 1. So 3x squared minus the 3x, there's the minus x, and then there's the plus 1. Okay, so I just split negative 4x into negative 3x and negative x. Now I can draw my curtain. I can pull out a 3x. That will leave me with x minus 1. There's a negative there, so I've got to pull out the negative 1. That will also leave me with x minus 1. Okay, so this is going to be x minus 1 times the stuff on the outside, 3x minus 1. Okay, but you can't forget this guy right here. We pulled out that GCF of x, so times x. You can put that on the front side, doesn't matter. Okay, so now when I solve all three of these, I flip that sign. So one of my zeros is 1. Move the 1 to the other side, divide by 3. That's going to be 1/3. And when I set that equal to 0, I literally get 0. Okay, so I got the 1, the 1/3, the 0, but also we can't forget the original one that we tested. Okay, so I have another 1. And remember, guys, we have a quartic. We have an x to the 4, so I should have 4 roots. Okay, there are my 4 roots, the 1 twice, the 1/3, and the 0. So I would say, so there's a couple of different ways you can write this. You could write them out like this, that's fine. But the directions say to state the multiplicity. So I would say on this one we have for x equals 1, I would just say there's a multiplicity of 2. Sorry, can y'all see that? Yeah. X equals 1, there's a multiplicity of 2. Now on the quiz, we'll have our normal chart. You know, the zeros and the multiplicity, and you would just say 1, you would say multiplicity of 2, and then we would have our 0 and 1/3. And the rest of those would be multiplicities of 1. Okay. Just make sure y'all are. Get my webcam to focus again. Okay. All right. So yeah, these are a little tricky, guys. A little tricky. It's advanced algebra, and this is the gifted and the block class. I gotta push you guys to the limit. I could make these problems a lot easier. I actually did create this file. I could have made these a lot easier, but gotta push you guys and challenge you. You'll be thankful when you get to college and you'll see a lot harder stuff. You'll be thankful that you were pushed in high school and things that the last thing you want to do is go through high school and everything's easy peasy. And you just make hundreds on everything. You don't have to work. You don't have to study. And then you get to college and you get hit on the head with a sledgehammer because everything's very, very difficult and you've never had to work for anything. Okay, so this next one here, I've got 3x to the 4th minus 2x to the 3rd plus 5x squared plus 2x. Okay, if I draw my curtain here, grouping's not going to happen. I would have a 3 and a 2 and then a 5 and a 2, and that's not going to happen. So here, if I wanted to, I could go ahead and pull out the x on the front side, and we can do that. Let's go ahead and do that. So I'm going to factor out an x. That's going to leave me with 3x cubed minus 2x squared plus 5x plus 2. Okay, we don't forget about that guy. So I know one of my zeros is going to be the 0 because I just have a GCF, a single x there. Okay, so now I can't factor this. So now I got to go back to my. Oh, I forgot to give you guys the possible rational roots for this. I'm gonna write it. I'm gonna write it down here. Possible roots. I'm gonna write. We got 0 plus or minus 1 plus or minus 2 plus or minus 1/3 and plus or minus 2/3. Okay. So just keep in mind these are our possible roots for this problem. All right. So let's go to our graphing calculator. Let's type in our function 3x raised to the 4th. Minus 2x raised to the 3rd plus 5x squared plus 2x. All right, let's graph that. Okay, that looks like it crosses at 0. Okay, crosses at 0. All right, so remember this is a plus 0. Okay. All right, so let's go ahead and test 0. Test 0. All right, 3, negative 2, 5, 2, and 0. That's going to be 3. That's going to be 0, negative 2, 0, 5. So these are all just 0. 0 times everything is just 0. Okay, so that takes me down to, now I have 3x to the 3rd minus 2x squared plus 5x plus 2. Okay. So now, can I factor that? It's the same thing. If I draw my curtain here, I'm not going to be able to factor that. I got 3's and 2's over here and 5's and 2's over here. So I've got to figure out another factor that I need to test. Okay. Well, let's look at our possible possible rational roots here. Okay, so I've got, and by the way, let me back up real quick. I don't think I fully clarified this. When you have a 0 here, when you have a 0 for a constant, the way that you're going to come up with your possible rational roots is, if that's a 0, then obviously one of your possible rational roots will be 0, and then you default to this guy. Okay, so then you go to your 2x, your next term. Okay, so the way that we got all these numbers, if you do your p's and q's, I have my on top I've got my plus or minus 1 and 2, and on the bottom I have my 1 and my 3. So that's how I come up with the 1, the 2, the 1/3, and the 2/3. I don't think I fully explained that very well over here on this one. Okay, so on this one we had a 0, so one of our possible roots is 0, and then we default to this negative. We default to this 1 over here. So on top you've got 1, and on the bottom you've got 1 and 3, and that's how we got our 1/3. So I just want to make sure I clarified that so you're not confused on that. Okay, so we're going to test one of our possible rational roots is 1/3. So if I go back and look at my graph, that looks like maybe possibly it crosses at negative 1/3. Okay, maybe it's negative 2/3, but to me it looks like it's closer to 0 than it is to negative 1. So I would say this is probably going to be, I'm going to test negative 1/3. Okay. All right, so I'm going to have, so now I'm doing synthetic division on this guy, okay, not the original. Once you do synthetic division twice, you keep doing it based on your smaller degree polynomial. You're going from a 4th degree down to a 3rd degree down to a 2nd degree. So I'm going to do it on these guys right here. 3, negative 2, 5, and 2. Bring down the 3. Negative 1/3 times 3 is a negative 1. Negative 2 minus 1 is negative 3. Negative 1/3 times a negative 3 is a positive 1. 5 plus 1 is 6. Negative 1/3 times 6 is a negative 2. And as we anticipated, we get a remainder of 0. So now I'm down to a 3x squared minus 3x plus 6. Okay. And now how do I factor this? Okay, well, these are tough, guys. These are some challenging problems. Okay. If you factor out a GCF of 3, you would get x squared minus x plus 2. What are the factors of positive 2 that add to negative 1? There aren't any. Okay, so once again, we cannot factor this. Okay, and this should make sense to you guys. If I look at my graph, it looks like it might possibly cross in 2 spots. But this is a quartic, so I have 4 roots. Okay, that means probably 2 of them are going to be imaginary. Okay, so I'm going to have to use quadratic formula again. So my A is the 3, my B is the negative 3, and my C is the 6. Okay, so I've got negative B, negative 3, plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. I'm going to come down here to give me some more room. That's going to be positive 3 plus or minus, type all that in your calculator. You should get negative 63 and over 6. Okay, can the square root of 63 break down? Yes, it can. That can break down into the square root of 9 and the square root of 7. So that's 3 root 7. So this simplifies to 3 plus or minus, there's an I that pops out because there's a negative, so that's going to simplify to plus or minus 3I root 7 over 6. All 3 of these guys are divisible by 3, so that is going to be 2 plus or minus I root 7 over 2. Sorry. 3 divided by 3 is 1. Okay, and that's part of the reason why you guys are learning how to do these long, complicated problems is, can I navigate through a whole problem without making a mistake? Nobody's immune to making mistakes. You're not immune. I'm not immune. Everybody makes mistakes. But can you go back and check your work and make sure that you are catching your mistakes? And do your answers make sense? If I got a 0 of 2, does it cross the x-axis at 2? That kind of stuff. Okay, but that's not my final answer. Those are 2 of my roots. Okay, so 2 of my roots are 1 plus or minus I root 7 over 2. And I have 2 more roots. I have this guy that we tested, the negative 1/3, and I have the 0 that we tested, 0. Okay, and that is our final answer. Okay, let's keep going. Last one here. This one looks more complicated. This one, to me, in my opinion, is actually easier than the ones that we just did. Okay, so I can't factor this. I can't draw my curtain thing. I can't pull out a GCF. So if I go to my graph here, I'm going to type all this in. I've got x raised to the 6th minus 2x raised to the 4th minus 11x squared plus 12. Okay, let's graph that and get some starting spots. That doesn't look so bad. That looks like it crosses at -2, -1, and 1 and 2. Okay, well, let me list your possible roots are, your leading coefficient is 1, so it's basically just the roots of 12, or factors of 12. So you got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Okay, so it looks like it crosses at -1. Let's just pick one. Let's test. Actually, I'm gonna start with 1 just to be consistent with my other key. But it doesn't matter. You'll get the same answer regardless of where you start. Okay, be careful here, guys. When you do synthetic division, you got to fill in the gaps. There's a 1 at the 6th. There is no x to the 5th. -2. There's no x to the 3rd. -11. There's no x, and then there's a 12. Okay. Bring down the 1. 1 times 1 is 1. That's 1. 1 times 1 is 1. That's -1. That's -1. That's -1. That's -1. That's -12. 1 times -12, that's -12. 0 plus -12 is -12. 1 times -12 is -12. Those guys cancel, and here we get a remainder of 0. Okay, so we took our x to the 6th, and now we got it down to an x to the 5th. We got it down to a quintic. Well, we got to keep going. Okay, let's go back to our graph. Looks like it crosses at 2. Let's test 2. But now I'm going to do synthetic division on those guys. 1, 1, -1, -1, -12, -12. All right, bring that down. 1, 2 times 1 is 2. That's 3. 2 times 3 is 6. That's 5. 2 times 5 is 10. That's 9. 2 times 9 is 18. That's 6. 2 times 6 is 12. They cancel. We get a remainder of 0. We're still not anywhere close to a quadratic. Okay. Let's keep going. Let's test the negatives. Let's test -1. I'm doing that on these guys. 1, 3, 5, 9, 6. Bring down the 1. That's -1. That's 2. That's -2. That's 3. That's -3. That is 6. That's -6. And they cancel. Here's our remainder. I still don't have it down to a quadratic. That's still a cubic. All right, we got to do it one more, boys and girls. Let's test the -2. Okay, and I'm doing that on these guys. 1, 2, 3, 6. Bring down the 1. That's -2. That's a 0. That's 0. That's 3. There's our -6. They cancel. Now we've got it down to our quadratic. That's the constant. That's the x. That's the x squared. So the x squared plus 3 equals 0. Please don't do quadratic formula on that. This is just simple square root method we learned last year in geometry. Get the x squared by itself and take the square root of both sides. But I can't take the square root of a negative. That's where the i's come in. So x is going to be, and I always generate a plus or minus when I take the square root of something. So that is just going to be plus or minus 3i. Okay. Or excuse me, let's back that up. That is going to be plus or minus I times the square root of 3. Okay, sorry. I pops out, plus or minus I root 3. Okay, so We got a whole bunch of zeros here. How many zeros should I have? I should have 6 zeros. Okay. There's a 0, there's a 0, there's a 0, there's a 0. So I have 1, 2, -1, and -2, and then my two imaginary solutions are the plus or minus I square root of 3. Okay. So that is the front side. All right, now let's go ahead and switch on over to the back side. All right, so now we've got some graphing here. So this is graphing polynomials and the end behaviors and the absolute maxes, relative max and mins. Didn't quite have a chance to get to the relative max and mins and the absolutes in class today, so that's why I'm making this video to go ahead and go over this now. All right, so when you're giving a graph here, the first thing we'll do is find the zeros. Okay, so to find the zeros here, we're going to use, we can't factor this because that's just 1, and we got 14s and 24s over here. So I'm going to go to my calculator. I'm going to graph this, x raised to the third minus x squared minus 14x plus 24. Okay, let's graph that. Alright, so it certainly looks like it crosses at -4, 2, and 3. Okay, so let's just check that. Let's verify that very quickly. So let's test -4. Okay, so we've got 1, -1, -14, 24. Bring down the 1. That's -4. That's -5. That's 20. That's 6. And there's my -24. They cancel. Alright, so then that gives me x squared minus 5x plus 6. That's easily factorable. That is just x minus 2 times x minus 3 equals 0. So my zeros are 2 and 3 and the -4 that we tested. So that's straightforward. -4, 2, and 3. That's all those have a multiplicity of 1. Okay, this is a cubic, right? That's a cubic. If one of these had a multiplicity of 2, that would mean it's a quartic. Okay, so that makes sense. They all have a multiplicity of 1. All right, so now for the end behaviors, okay, this is odd. And the leading coefficient is positive. Okay, so that's my, if it's odd, it's my snake. Okay, this is my regular snake because it's positive. So this is going to be down, up. Alright, so the way I want to see it written on the quiz, guys, is I want to see as x approaches infinity and as x approaches negative infinity, where are my y's headed? Okay, if my snake is going like this, as x goes this way, as x goes to the right, my y's are going up. My company's making money, so y is headed towards positive infinity. As my x's go this way towards negative infinity, notice my y's are going down. So that's headed towards negative infinity. Okay, all right, so we need to, now domain and range. Domain is just like we learned last year in quadratics. If I have a quadratic, the domain is all real numbers. I'm always going to have x values, no matter if my graph goes up or if my graph goes down. It's going to be the same thing for cubics, guys. If it's a snake, backward snake, if it's an M or if it's a W, whatever, I'm going to have x values everywhere. So domain is always going to be negative infinity to infinity. All right, so now we get into the range and the absolute and the relative max and the min. Okay, so just real quickly to refresh your memory, if I have something like this, a graph that does this, these guys right here are called relative maxes and relative mins. It just means it's just a small hump in the roller coaster. If I have something like this where I have something comes down, makes a relative min, makes a relative max, comes down here, and then makes a bottom, we would call that guy, that's an absolute minimum, okay, because there's nothing else lower than that, okay? So you could have an absolute min or absolute max. It's just the lowest or the highest spot on the graph. These guys up here, those are relative maxes and relative mins, okay? It's pretty self-explanatory. It's intuitive what you think it might be. So now we learned in class how to just sketch these graphs. But now I can actually use my graphing calculator to go find these actual relative mins and maxes. Okay, so the way I'm going to do that is I'm going to graph this on my graphing calculator, which I've already done. And now I have my graph goes way up here. I know it's going to be an S. Okay. So my graph goes way up here somewhere. So I want to find out where does this graph make its absolute or make its relative max or min, okay? Because it's an S, okay, I have no absolute max or min. There is no low spot because these guys go on forever and these guys go on forever. So there's no absolute high or low spot on my graph. However, we do have a couple of relative maxes and mins. I have a relative max that somewhere comes up here and the roller coaster turns over, comes down here, and then I have a relative min down here. And the way that we find these spots are our good old friend Mr. Spidey. Okay, Mr. Spidey is found under calc. So I'm going to go second calc, and now I'm going to use Mr. Spidey to find these maxes and mins. Okay, so the first one that I want to find, I could go ahead and find the maximum. So I'll press 4. Okay, so now your calculator, just like I taught you guys last year, now if you had me last year, your calculator is saying, Mr. Manise, I need you to give me a spot to the left of the max and to the right of the max. It wants a left bound and a right bound. It doesn't know where to start. It doesn't know whether you want this spot or this spot, so you have to tell it. All right, so what I'm going to do is I'm going to move Mr. Spidey on the spider web. Now, to find Mr. Spidey, you just watch the X and Y coordinates on your graphing calculator. Right now, Mr. Spidey is sitting at 0, 24. So he's sitting way up here at 24. I need to move Mr. Spidey somewhere to the left. Now, this spot is -4. So I'm going to move Mr. Spidey until I can see him down here on the left side of my max. So I'm going to slow down. I should see him here quick. There he is right there. There's Mr. Spidey. He is to the left of this maximum that we can't see on the calculator. So that's fine. Anywhere to the left. I could go down here. I can go up here. Anywhere as long as I'm comfortable, I'm to the left of the max. That's good. I'm going to press enter. Now my calculator says, Mr. Manise, I need you to move Mr. Spidey to the right of the maximum because I'm trying to bracket. I'm trying to bracket where this maximum is. Okay, so if I were to just draw a sketch up here, say I have some kind of max right there, your calculator is trying to bracket that one spot. So it needs a left bound and it needs a right bound. Okay, in case that's never been explained to you guys. Okay, so now I need a right bound. So now I just need to move Mr. Spidey. I'm pressing to the right here. I'm just tapping, pressing to the right. I just need Mr. Spidey to be somewhere to the right of it. Well, there's Mr. Spidey. Okay, so he's to the right of it. Press enter. And now notice, guys, I've got it bracketed. I've got Mr. Spidey on the left. I've got Mr. Spidey on the right. Now my calculator says, Mr. Manise, do you want me to find this spot? Do you want me to guess? Yes, Mr. Calculator, I want you to guess. I'm going to press enter one more time. And whoops. Let's try that one more time. Okay. Maximum. Move Mr. Spidey to the left. Okay, that's good right there. Move Mr. Spidey to the right. That's good. Press enter. Press enter. And I'm not sure where it gave me an error just now. And then it spits out the maximum right there. Okay, so I have a relative maximum. I have a spot in the roller coaster that turns over at -1.85 and 40. Okay, so I'm going to say a relative max. Got a relative max at -1.85 and 40.15. Okay, that's that spot. Okay, let's go ahead and list our zeros here. I got a 0 at -4, I got a 0 at 2, and a 0 at 3. Okay, just from our chart here. Okay, but what about this guy right here? That's a relative minimum. So now I'm going to go second calc. I'm going to select minimum. And now I need a left bound. I need to bracket this spot. So this will be a little bit easier to see because you can actually see the bend. If you're not sure where Mr. Spidey is, just watch these coordinates here. I should see him. Okay. There's the left. Anywhere to the left, guys, is good. That's fine. That's fine. Anywhere, that's good. Press enter. Now move Mr. Spotty somewhere to the right. Up there. I'll go off the screen. It doesn't matter. Press enter. Yes, I want you to guess. Press enter. And it spits out our relative minimum, which is 2.5 and negative 1.6. Minimum 2.5. I'll round it to the hundredths place, even though I can't really graph that with the naked eye. Okay, so now that we have these relative maxes and mins, now I can go do better than what we did in class, where I can sketch a more accurate graph. I know it's going to be a snake. It's going to start down here. So my graph is going to come up here. All these multiplicities are 1, guys, so it's going straight through the x-intercept, straight through the x-axis. It's going to come up here, and then somewhere around almost negative 2, somewhere up here, my graph is going to go all the way up to 40. Whoa. So I'm just going to do some dotted lines up there. It's going to turn over there somewhere. It's going to make a relative max, and then it's going to come back down, and then I'm going straight through 2, and then I've got this relative min at 2.5, negative 1.6. So that's about 2.5 and almost negative 2. That's that spot right there. So there my graph is going to turn around there, and it's going to go back up through my other 0 of 3. Okay, now guys, this is not, I don't want you guys to get confused. Some of y'all may be thinking, well, wait a minute, that's the kiss and run, right? This is not a multiplicity, because the multiplicity are only for the zeros, right? The x-intercepts. That's just a turn in the roller coaster, all right? So don't get confused there. Okay, so that is the sketch of this graph, okay? All right, now range. I shouldn't have to talk too much about range. You guys have been doing range for years. Karate Kid, right? Paint the fence. Paint the fence. Range, I'm sweeping from bottom to top, and I'm asking myself, where do I have y values? Put an arrow there. Do I have y values down here at negative infinity? Yes, I do. These guys are going forever. So I've got y values at negative infinity, and then I have y values until what? Positive infinity. I have y values everywhere. Okay, I have no absolute max or min. It doesn't top out or bottom out at any spot. So my range is negative infinity to infinity. Okay. All right, let's do another one of these. Okay, so let's type this next one into our calculator. X raised to the 4th plus 4x raised to the 3rd minus 5x squared minus 36x minus 36. Let's graph that. Let's get some starting spots. Okay, that certainly looks like it crosses at negative 2. Okay, it also looks like it crosses at 3. That's pretty clear cut. So why don't we start with 3? So I'm going to test 3. That's going to be 1, 4, negative 5, negative 36, negative 36. Bring down the 1. That's 3. That's 7. 3 times 7 is 21. That's 16. 3 times 16 is 48. 48 minus 36 is 12. 3 times 12 is 36. They cancel. All right, I'm still not down to my quadratic though. Okay, so let's test negative 2. All right, so I have, now I'm testing it on this. So I have 1, 7, 16, 12. Bring down the 1. Negative 2 times 1, negative 2. That's 5. Negative 2 times 5 is negative 10. That's 6. That's negative 12. That's 0. I know I'll go through the synthetic division kind of fast, but at any point in the video, guys, you can pause the video, rewind. I love the little 10-second backwards thing on YouTube if you want to go a little bit slower. I just don't want these videos to be too long. All right, so now I'm down to my quadratic. So now I have x squared plus 5x plus 6. That's easily factorable. That's just x plus 2, x plus 3. So my roots, my zeros are negative 2, negative 3, the 3, but then I've got this negative 2 twice. Okay, so I'll write it out here, but up in my chart I'm going to write 3, -2, -3, and they all have a multiplicity of 1 except for the -2 because it showed up twice. It showed up when we factored it and when we tested. Okay, so now let's look at our end behaviors. So my end behavior, this is even, and it's positive. That is going to be up, up. As x goes to infinity, as x goes to negative infinity, where are both of my y's headed? They're both headed up, up, up. So this is going to be our w. Both of your y's are headed up. Positive infinity and positive infinity. Okay, so let's go ahead and put our zeros on the graph. I've got 3, I've got -2, I've got -3. Okay, those are my zeros, my roots, x-intercepts. And now we got to look at our graph and find our relative mins and our relative maxes. Now this is an even. Okay, if you have an odd function, guys, then your range is going to be negative infinity to infinity because your s is going to go on forever. If it's even, you're either going to have a w, you're either going to have an m, or you're going to have a w, right? So if you have m's or w's, that means at some point you are going to have an absolute max or min at these spots where the roller coaster turns over. Okay. So I already know I'm going to have an absolute min here. This thing's going to bottom out at the very bottom. Okay. So let's go ahead and find this minimum. So I'm going to go second calc, minimum. All right, so let's move there he is. I just need him to the left. It goes way down here, but I just need Mr. Spidey to the left and Mr. Spidey to the right. So that's good. Press enter. Let's keep on moving Mr. Spidey over. Once I start getting close to 3, I should see him. There he is right there. That's to the right of it. That's good. Press enter. Yes, I want you to guess. Press enter a third time. And there is our absolute minimum, 1.68. So we have a absolute minimum at 1.68. That's not a negative. 1.68 and negative 83.66. Okay. All right. That's our absolute minimum. Okay. And what about the relative max and the relative mins? I'm going to have a relative min there, and I'm going to have a relative max right there. So let's go find both of those. Doesn't matter. Let's find the minimum first. So let's move Mr. Spidey back to, okay, I just need a spot to the left of that minimum. That's good right there. Press enter. You got to be careful here. You want to go barely just to the right of it. You don't want to go past the other one because you're going to get an error on the bounds. Just barely 1 or 2 clicks to the right of that minimum. Yes, I want you to guess. And there is our relative minimum, negative 2.68 and negative 0.84. So for the relative minimum, I'm going to have negative 2.68 and negative 0.84. And for the relative max, I'm going to do it one more time. Mr. Spidey's second calc. Let's find the relative max. Okay, I need to be to the left of the max. That's good right there. Move Mr. Spidey just a little bit to the right of the max. That's good. Yes, I want you to guess. There's our maximum at negative 2, 0. But we already knew that because we knew that negative 2 was one of our zeros. So I just want to kind of demonstrate that so you guys can make that connection. Our relative max is sitting there at negative 2, 0 because our relative max is an x-intercept. Okay, that's our kiss and run, right? It goes up, hits that x-intercept, and then bam, runs off. Okay, so now I'm ready to actually sketch a graph. So this is going to be our W. Okay, so it's going to be up, up. So what happens at the negative 3? That just goes straight through. Okay, so it's going to come down here straight through the negative 3. And then we're going to have our first little minimum right there. So at almost negative 3, almost negative 1. So that's going to be somewhere about right there. It's going to hit that relative minimum, and then it's going to come back up, and then it's going to hit our 0 of -2. That's a multiplicity of 2, so that's a kiss and run. Okay, so then it's going to fall off, and then our absolute maximum is down here at 1.68, -83. Okay, so about at -1, which is about right there, it's going to go off the chart all the way down to -83, and then it's going to come back up, and then what happens at +3? That's a multiplicity of 1, so it's going to go straight through 3, and we can put our arrows on that. Okay, and is that not, and of course you can verify this, guys. You can just verify that your graph looks like this graph. Okay, use the graph as a backup to check. All right, one more, guys. We can do it. I know this is a long video, but this is some pretty complicated stuff here. The quiz won't be near as long as this quiz review. I might just give you a couple of these and maybe just 2 or 3 of these, so you'll have plenty of time to get these done in class. But if you can do all these, then you're golden on the quiz. All right, so this last one here, let's go ahead and graph this. Oh, I'm sorry, I almost forgot this. Domain and range. Domain is always -infinity to infinity. Now the range here, guys, though, we do have a range. Okay, I don't have y values down here at -infinity. I don't have any y values until I hit this spot, which is a y of -83.6. Okay, so my range, as I paint the fence, Karate Kid, as I paint the fence, I will hit that -83.6, and then I will continue to have y values forever and ever. Okay, so my range starts at -83.66 and goes on to infinity. Technically, yes, we need to put a little bracket right there because we are including that point. Just a little technicality. All right, let's do the last one here, and we'll be done. Okay, let's type this in. 2x raised to the 4th plus 6x raised to the 3rd minus 2x squared minus 6x. Okay, let's graph this guy and see what we got. I love this stuff. This stuff is fun. All right, so here's our w as we expected. It's even and it's positive. All right, so it certainly looks like it crosses at 0. But also, guys, if you take a look at this, what I've been saying this whole time is what's the first thing you want to see if you can try to do, and see if you can factor it. Okay, now you can keep doing this. You can do this. You can do the synthetic division. I'm going to go ahead and change it up, and I'm going to see if I can factor this guy. Let's bring this down here. I got 2x to the 4th plus 6x cubed minus 2x squared minus 6x. It certainly looks like I can factor it. Let's draw our little curtain here. I can pull out a GCF of 2x cubed. That will leave me with x plus 3. That's a negative, so I've got to pull out the -2x. That is going to leave me with x plus 3. Check it. Yep. Okay. So I have x plus 3. Then I have the stuff on the outside, 2x cubed minus 2x. Okay. Now you could have noticed up front that all of these have a GCF of x. Okay. They also have a GCF of 2. And this is why I love math. You could have done this literally 3 or 4 different ways. Okay. I chose to do it this way. So one of my factors is x plus 3. Now I'm going to factor out of this, I'm going to factor out a GCF. Okay, so I've got my x plus 3. Can't forget about that. I'm going to pull out a 2x here. 2x. That is going to leave me with x squared minus 1. Okay, so I have the x plus 3. I have the 2x GCF. I have the x squared minus 1. Okay, but what is x squared minus 1? That's the difference of squares. Okay, so we have 2x is our GCF. We have the x plus 3. And then we have x plus 1, x minus 1. Okay, there are our 4, circle this, there are our 4 zeros. Okay, if I set 2x equal to 0, I just get 0. Flip that sign, flip all these signs, and there are my 4 zeros. Okay, so I'm going to go back up to the chart here. -3, -1, 0, 1. These all have a multiplicity of 1. They only show up once. Okay, so in behavior, this is even, and it's positive, and so that means it's going the leading coefficient is negative, so that means it's going to be up, up. Okay, so we're going to have a W, another W. All right, so we could say as x goes to infinity, x goes to negative infinity, which way are my y's going? Once again, they're both heading up. All right, so now let's go ahead and list our zeros on the grid. We've got -3, -1, 0, and 1. Wish they made these graphs a little bit bigger. Alright, so now we need to look at our relative mins, absolute maxes, and mins. Since it's even, I'm going to have a relative, I'm going to have an absolute max or min. Since it's a W, I'm going to have an absolute, an absolute min. So let's go find that first. Second calc, let's find the minimum. I need to move Mr. Spidey somewhere to the left. That's good, there he is right there. He's to the left, press enter. Move Mr. Spidey to the right. There he is, that's good, press enter. Yep, press enter again. And there is our relative, or excuse me, I keep saying relative, is our absolute, that is our lowest point on the graph, is sitting at -2.3 and -13.8. So under absolute max, I'm going to say we have a min, that's an absolute minimum, at -2.33, -13.83. Okay, now we need to go find these other relative max and mins. Let's go find the maximum first. Let's go Mr. Spidey somewhere to the left, that's good, press enter. Let's go somewhere to the right, that's good, press enter again. There's our relative max, -0.53 and 1.88. So for the max, I have -0.53 and 1.88. For the min, I have, we haven't found that yet. Let's go find the min. Second calc, minimum. Okay, let's move Mr. Spidey just to the left of the minimum. That's good right there. And if you get these backwards, guys, watch what happens. If you start on the right and you go backwards, then your calculator, oops, let's try it again. Minimum. If you get these backwards, go, and then the right bound, then your calculator is going to explode. It doesn't know what to do. You're saying what your calculator doesn't understand that. Okay. All right. So let's go second calc minimum, just to the left of the minimum, just to the left of that spot. That's good. Move Mr. Spidey to the right. I'll go way up here. Doesn't matter. That's good. Yes. Press enter a third time. And there's our relative minimum at 1.68 comma. Oh, sorry, I did the wrong problem. 0.61 comma -2.77, which is that number right there. These two numbers. Okay, so now our domain is always -infinity to infinity. All right. So before I do the range, let's go ahead and plot this so we can make the connection. All right, it's going to be up, up. Okay, so what happens at -3? It's going to go straight through it. That's a multiplicity of 1. Okay, so I'm going through -3, and then I got to go all the way down here to our absolute minimum, which is at -2.3, almost -14. So somewhere down here at almost a little over -2, at some point I'm going to go off the grid, and I'm going to hit this -13.83 number, and then I'm going to come back up, and I'm going to pass through -1, multiplicity of 1. Then I'm going to hit our relative max at -0.53 and 1.88. So that's about right there. And it's going to turn over, and then I'm going to go back through 0, and then I'm going to hit our minimum, which is at 0.6, relative minimum at 0.61, -2.77, which is about right there. It's going to hit that spot, turn over, and go back through our 0 of 1, and there's our graph. That's a lot. Okay, does that look like what's on the calculator? Yes, it does. Okay. Now our range, once again, if I've got an absolute minimum, my range starts with this value. So I'm starting, my y values don't start until I hit that guy, and they will go on forever. I've got y values forever and ever. Okay. Whew. Tricky stuff, guys. I love it. It's a lot of math, a lot of thinking here, but it's great critical thinking skills. Hope you guys enjoyed this. I wish you good luck on your quiz, and we will see you on the next video.